Right, the next variant we are going to look at is called multi-level queue scheduling. So this is actually a modified or an improvised version of the priority plus round robin combination, which I discussed in a previous segment. So in that, what you had is you had one queue, everything had priorities. You picked up the highest priority task and you ran it for a particular time slice. Then you picked up the next highest, you ran it for the same time slice, and so on, right? Here what we do is we have multiple queues where different types of processes are put in different queues. So your processes, you classify them based on certain criterion into different types, and you have a separate queue for each type of processes. The processes pertaining to a specific type go into that queue, and within the queues there is a priority. Like real-time processes are highest priorities, they need to be done first, followed by system processes, followed by interactive, followed by batch processes. So within the queues you will use priority to choose which queue works first, and once a queue has been picked, the processes inside that queue you can use round robin generally, but you can also use first come first serve, shortest job, shortest remaining time first, any of the things you have learned so far. So what happens here is, all this while we had one queue and multiple processes. Now we are splitting the queue itself into 4 to 5 sub queues depending upon what type of processes. So the processes, they go into the corresponding queues. The queues themselves are executed in the order of priority. The highest priority goes to real-time queue and lowest priority to batch queue. So within highest priority, so the real-time queue should be emptied first, and then the system processes queue, then the interactive queue, then the batch queue. So now in the real-time queue, within that we generally use round robin, but you can also use FCFS, SJFS, SRT, F, or whatever algorithm of or priority inside that also, your choice. So again, whenever you have a priority element involved, starvation is possible. So what if tasks keep getting added to this queue on, and you are just not able to empty this? You will never be able to move to these, right? So that is a problem with multi-level queue scheduling. So to overcome that problem, we have multi-level feedback queues. So this again is an improvised version of the aging logic which we saw to combat starvation in priority scheduling. So multi-level queue, again you have multiple different queues, different types. The queues have a priority. Within the queues you have processes, and the most important queue will be resolved first, followed by the next, and so on. Everything is the same as multi-level queue. But to solve the starvation problem in multi-level queue, which is for the most important queue, processes might keep coming, right? And if they never end, then you never empty this queue, you're never going to go to this queue. So again you set a time slice. After the time slice, the processes get promoted from one queue to another. So in aging, if you remember, we saw the priority of the process increases by 1 unit after a specific time slice. Here, that's what is happening. The process moves from a low priority queue to one step higher priority queue after a specific time slice. So if it keeps waiting for a long time, it keeps getting pushed until it goes to the topmost or the highest priority queue. So ultimately at some point this process will get executed. No process will have to wait indefinitely. That is called multi-level feedback queue scheduling.